Welcome to Mancinelli's Math Lab. Thank you for subscribing. This is a requested video, so let's cover that now. I have two discrete random variables. The first one I called N1, and that's going to represent the number of claims received in week 1. So we're told that the number of claims received in a given week is a discrete random variable, and actually, well, they give me the PMF as well. I'll write that down. So what I can say is I'm just going to name a new random variable. That will be the number of claims in week 1. Another one for the second week, so number of claims in week 2. And they want me to find the probability that the number of claims in the first 2 weeks is exactly 7. So they actually do give me the PMF, the probability mass function. And they give me that to be this, which is the probability that n is equal to n. And actually, let me just say this. Let me just say ni equals little ni is 1 over 2 to the ni plus 1, actually, right? Plus 1. Where I is equal to 1 or 2. So all I'm saying here, this might look kind of fancy. It's not fancy. All I'm saying is that these two PMFs, the probability mass functions, are identical. They're both given by this geometric looking sequence thing, right? All right. So we're also given one other piece of information. That is, the random variables are independent. The number of claims received in a given week is independent for any other week. So namely, week 1 and 2, claims received in week 1 are independent of that in week 2. So we also have that the probability N1 and N2, is probability N1 times probability N2. By independence, right? Hopefully you agree. By independence, we have that business. Now, let me put over here because I want to help you visualize something. To me, it's not quite apparent as of yet where we're going to use independence. It's not obvious to me yet, so I'm going to put N1 here and N2 here. Now, let's write down what it is we're looking for here. We want this quantity right here. Now, the thing is you don't have to really do too much math to actually solve this. Just think about the combinations of N1 and N2 that give you exactly 7 received claims. If you like, you can have a picture over here. Let's make this right here and somewhere right here, right? We're going to have several dots, discrete points. We could have, in order to get the N1 and N2, them to add to 7, we could have 0 N1s and 7 N2s, so I'd call this 0, 7. I could also have 1 and 6. I could also have 2 and 5, etc., down to 7 and 0, right? Because here, this ordered pair represents 0 claims in week 1, 7 in week 2, 1 in week 1, 6 in week 2, etc. We could just count those actually and be done. So you could do that. Or we can be a little more mathy, and that's what I'm going to do. So let me just write something down here. Think about what I just said. 0, 7, 1, 6, 2, 5, 3, 4, right? 4, 3, etc. Now this expression here is equal to, this is equal to the probability that N2 is equal to 7 minus N1. Now, I want you to think about this for a second. This exactly follows with what I was just saying over here. Look at my points over here. N1 can be 0. Oh, then N2 is 7. N1 can be 1, then N2 is 6. So we need to throw in another piece here. Okay, so let me just write this. So 4 n1 equals 0, 1, 2, dot, 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 up to 7. So we need all of these. And if you think about it for a second as well, we need to compute the situation where probability n1 is 0, probability n1 is 1, 2, up to 7. So just bear with me here. This is equal to the following. This is equal to the probability that n1 just equals one of those numbers. It just equals one of these numbers. Once I've chosen a number for n1, that automatically dictates what n2 is. So I just let n1 vary, and then n2 just is given by the relationship involving n1. So like this, right? n2 is 7 minus n1. So again, n1 equals 0 up to 7. So hopefully this is clear to you. And well, I'm not just going to evaluate these individually. The way you can think about this is, in order to compute this, we need the probability basically that n1 is 0, or n1 is 1, or n1 is 2, up to 7. So hence, this business here, the probability that n1 plus n2 is equal to 7 is the sum n1 equals 0 to 7 of this guy, right? Because hopefully you're seeing that I need to basically attribute, I need to account for all of these values of n1. And I'll do that by giving a sum, okay? Probability n1 is equal to little n1, and n2 is equal to 7 minus n1. All right, I'm going to write one more step. This right here, basically, by the way, is the joint mass function. So now this is an AND statement, and we know that these two random variables are independent. So this is equal to the sum, n1 equals 0 to 7, probability n1 equals n1, and times the probability n2 equals 7 minus n1. Now let me point something out terminology-wise. This is usually, right here, this is usually what's called the formula for the convolution. This is a convolution here. So hopefully you've seen this terminology before. I personally never try to, well, remember the convolution formula. I just go about it logically in this way. All right. I just need to compute this, and I will be done with it. So let me give myself a little more room, and we'll have it. Let's just keep in mind what I have there. We're almost there, so we can answer this question. All right. So the probability that we're after, the probability that n1 plus n2 is equal to 7 is equal to the sum n1 equals 0 to 7 of this expression, right? This summand right here. So this is probability n1 equals n1, probability n2 equals 7 minus n1. Let's just make a substitution into our mass function here. We can utilize this mass function for both of these expressions right here. So this gives me now the following. This is the sum n1 equals 0 to 7. Probably n1 equals n1 is just the mass function alone, so 1 over 2 raised to the n1 plus 1 times probability n2 equals 7 minus n1. So not much going on. I'm just going to replace the so-called variable here with this business right here. So this is 1 over 2 to the 7 minus n1 plus 1, right? Something quite nice happens here. I'm going to use properties of exponents to combine the two powers of 2. I can combine these. Notice what happens to my variable n1. So this is equal to the sum n1 equals 0 to 7 of, let's just add the exponents here and combine these, right? So this is 7 plus 1, which is 8, and then I have n1's cancel, and then I have a 1 here. So it looks like I'm getting 1 over 2 to the 9. That's quite convenient. Now, how do I finish this off here? Well, this is just a power of a half, so I can just really factor this out, and I'm adding up 1 8 times. So this is exactly 8 over 2 to the 9, which is 2 cubed over 2 to the 9, which is 1 over 2 to the 6, which is 1 over 64. Amazing. I actually carried out the entire problem for you. This is what I chose. This is how I chose to approach the problem. Tell me what you think. I hope it was helpful.